Hey everybody, we are talking today about data tables. Data tables, data. I say data. I think data sounds better than data. I don't know, whatever. So we're talking about data tables today. So again, we're still chugging along on the wheel of inquiry. We're still right here in this planning and testing phase, more so in the plan phase where we're not quite at the part where you start testing and gathering results. Yesterday, we talked about procedures and how procedures are super important in a scientific investigation, that they're numbered, short, easy to follow, include specific things, start with a verb or action word. All of those things are in a good, well-written procedure. Along with a procedure, or right about the time when you're writing your procedure, you also need to make a data table for your measurements and data to be written down in. So a data table is a chart that just organizes everything. Data tables should be organized before you start collecting your data, before you start your actual experiment, because you want to be able to focus on getting, writing down your results, and rather than trying to scramble and say, you've got results coming in and you don't know where to put them. They help also someone understand what your results were when you conducted your experiment. I remember there was this one time in college when I set up my whole experiment. It was on crayfish, and I was ready to go, and I had everything ready, and I started gathering results, and I forgot to make a data table, and I was panicking, and I put some data in one area and some data in a different notebook. And at the end, when all my data was collected, I couldn't piece out where all of my data was. So it's best to make one data table before you start collecting your data, just so that you're organized, and so that when you do start analyzing your results, you know where to look. So how do we set them up? How are data tables organized? There's kind of a certain way that we like to do this. And so that's what we're going to kind of go through right now. When you set up your data table, your independent variable goes on the left. So that's the yellow right here. Okay. Independent goes on the left, and your dependent is going to go on the right. Data tables also have titles. That's one thing that's an important thing. The best way to write a data table title, it's like a tongue twister. Data table title is to just write your question above the data table. A lot of kids write like experiment or my data. That's not a title. A title has exactly what your question is or what you're investigating. Sometimes they can look like this too. So we've got our independent variable here, but then a lot of times when we're collecting data, we do multiple trials, or we have multiple test subjects under our dependent. So you might see data tables that look kind of like this, and then they've got a spot for an average. You'll notice too, data tables always have straight lines. If you are doing this by hand, you use a ruler or a straight edge, and write neat and whatnot. So thinking back to our minion experiment, again, if you haven't watched that minion lesson, you're kind of out of the loop a little bit. But when we were looking at that minion experiment, we were testing, does the type of fruit that we show a minion affect their heart rate? And again, we were looking at excitement, right? And we were measuring that by their heart rate. So if I was going to set up a data table for that experiment, I would have my independent variable right here, which was the type of fruit. We've got apple, banana, and orange. What I'm measuring, my dependent, again, was the heartbeat or heart rate, which is beats per minute. And then you'll notice here, I've got 3 minions that I'm testing for each type of fruit. The more minions that you test, or the more test subjects that you have, the more reliable your results are going to be. And we actually call that in science sample size. So the larger the sample size, the more stuff you're testing your independent variable on, the more reliable your results are going to be. Because again, if I just tested one little minion here, he might be different in terms of what he likes versus, or how fruit affects his little body compared to these guys. So the more minions that I would test, the more accurate, reliable my results would be. So again, I've got independent here, I've got dependent over here, I've got my title. This is looking pretty good. So let's do some practice here. Think about this. It says, what question? So we're not actually making a data table. We are thinking of the question that's actually being asked based on the data table. So it says, what is the question that is most likely being investigated according to this data table? Now again, if we look back here, our independent variable is going to go on the left, and our dependent, what we measure, is going to go on the right. So in this question, whatever this is being investigated, this is going to be the independent variable, and this is going to be the dependent variable. So it looks like we've got how, or does, type of golf club affect what? Think about it. Does it affect the distance the golf ball goes? So in this experiment, the person who's running this, it looks like they're testing maybe 3 different types of golf clubs, and they're hitting the ball 3 different times with each type of golf club, and then finding the average distance that each of those golf clubs allow the ball to be hit. So how does golf club affect the distance, type of golf club affect the distance a ball goes? So that would be that question. How about this one? What question is being investigated here? Think about it. Again, we know that this is going to be our independent variable because it's on the left. This is our dependent, what's being measured. Think about it. I would say most likely the question that's being investigated is, does the type of cleaner, it looks like there's going to be 3 different types of cleaners because we've got 3 boxes. Does the type of cleaner affect the number of bacteria present? And it looks like they're doing 3 different dishes for each type of cleaner, which again is great. The more dishes that you would do, the more trials that you would do, the more accurate your results are going to be. So again, how does the type of cleaner that's being used affect the number of bacteria present? Let's look at this one. It says data tables help us identify trends and patterns. So we've got here our independent variable because it's on the left. Voice is kind of falling off the cliff here. We've got breed of dog, that's our independent variable. We got a little puggy, a lab, and a boxer. And we've got number of barks made per hour. And then, speaking of dogs, and looks like we've got 3 dogs for each of these breeds. So what this person was counting, or what this investigation was, is how many barks each breed does or barks in an hour. And they've got 3 of each of those breeds of dogs. So it says, again, data tables help us identify trends and patterns. So if we look here, the pug averaged 40 barks per hour. My dog barks a lot more than that. I don't even know if I'd call it a bark. It's more of like a snort, grunt thing. Okay. Thanks, Abe. All right, so sorry, I've got a little buddy with me now. So again, pug has 40 barks per hour. The lab has 5 barks per hour, and the boxer averaged out to be 15 barks per hour. So just looking at the data table, I can see that little puggy here is barking a heck of a lot more than the lab and the Boxer. So data tables help us identify trends, they help us identify patterns, just simply by looking at them and reading. Usually the next step is to graph the results. So sometimes when you have a huge data table and you have tons and tons and tons and tons and tons of data, like if we were to test 100 dogs or 100 different types of each breed, that would be a lot to identify trends and patterns. So a lot of times at this point, that's when, okay, Abe, you gotta go. That's when we would graph our data. Okay, so we'd make maybe a bar graph or a line graph. Now, when we are doing our clover experiment, we're gonna wanna set up a data table that looks something like this. So again, our question that we're asking is, does the amount of water that we give the clover affect the germination time, meaning the time it takes, the number of days that it takes to sprout up through the soil? Okay, so our independent variable is going to go over here. Our dependent variable is going to go over here. So think about how you would set this up right now. How would you set this up? What would you put over here? And what would you put right here? Think about it, think about it, think about it, think about it, think about it. Okay. Maybe pause if you need to think more. This is how I would set this up. This is how our data table is going to look. We've got amount of water, because that's our independent. And I said the other day, we're doing 5 milliliters per day, 10 and 20. Okay. And we're not just doing one plant for each of those. We're doing actually 5 different plants for each different amount of water. So I've got number of days to germinate or sprout, because that's what we're measuring. I got pot 1, pot 2, pot 3, pot 4, pot 5. So again, for each amount of water, I have 5 different pots, and I have a spot in my data table to find the average, which in a couple days we'll learn about how to do average and how to analyze some of our results once we have them. So that's what our data table is going to look like. Okay, so again, data tables are a way of organizing all of the results that you get, and you should always have them before you start collecting your data. Did you fart? Yes, you did. Bye.